Hi, everyone. I'm Hank Norris, Director of Strategic Partners at Ansys. We're excited to be sponsoring Microsoft Ignite and to be able to show you some of the compelling collaborations we've been developing between Ansys and Microsoft, as well as an announcement of a new product at the end of this video. Ansys and Microsoft have been doing great things together for years, and we have existing collaborations in several areas, including Office 365, autonomy, digital twins, and high-performance computing. For those of you who aren't familiar with Ansys, Ansys creates CAE multiphysics engineering simulation software for product design, testing, and operations across industries for organizations around the globe. In this video, we will show you a case for simulation in the Azure cloud using CFD simulation to design the optimal turbine blade for an autonomous firefighting drone. Then we have a video from Andy Chan, Microsoft Global Black Belt, explaining the advantages of simulation in Azure for the semiconductor industry, followed by an example of how Ansys solutions are seamlessly integrated into Microsoft 365. Please stay tuned at the end of this video for a new product announcement, and if you're planning to attend the Ignite event in Seattle, please stop by our kiosk in the industry area to chat with us and learn more about Ansys. Have a great event.
Greetings, Microsoft Ignite. My name is Nathan Moshman, and I run a small R&D company called Moshman Research located in Western Oregon. We seek to advance technologies the world desperately needs with advanced simulation and design optimization. That is why we partner with companies like 𝗦𝗲𝗀𝗀𝗀𝗀, who are developing a semi-autonomous, heavy-lift wildfire suppression platform. This technology will reduce wildfire risk with faster response time and more efficient fire suppression to prevent wildfire spread and keep communities safe and insured. The challenges with delivering an optimized design are numerous, even with the appropriate simplifications. It is too costly and time-consuming to fabricate and test several designs without optimization, and parameterizing the blade shape would take thousands of CFD simulations. This is prohibitive, with a model sized on the order of 1 to 10 million cells, required for the level of accuracy needed. And even with the Ansys tools, the simulation need to run on hundreds of CPUs in order to get a result fast enough for a streamlined workflow. We found that the new Ansys Cloud, powered by Microsoft Azure, was best suited for our needs. Large jobs are submitted directly from the Fluent interface without extra steps of uploading a project to the cloud. We found that the HBV3 virtual machines with 120 Milan X cores per node were optimally configured for our problem size, giving us fast results and minimal cost. Other general-purpose cloud computing services performed poorly in comparison, taking longer to set up a job, giving inconsistent runtimes, and losing a job not infrequently. If you want to do large Ansys simulations in the cloud, you want to use Microsoft Azure's Ansys Cloud Service. Our first round of adjoint-based shaped optimization achieved a 1/3 increase in thrust from the fan blades with a 12% increase in efficiency over the baseline shape. In our second round, at a slightly slower operating point, we achieved a 60% increase in thrust with no loss of efficiency over the baseline shape. Each design iteration ran overnight on our local machines. We would not have been successful without reducing that runtime to minutes, which we were able to do with Microsoft Azure's computing power. These proof-of-concept results are exactly what a partner like 𝗦𝗀𝗀𝗀𝗀𝗀 needs to show reduced technical risk to investors. If you do complex CFD analysis and design optimization to efficiently advance your technology, you need the software and hardware that are up to the task. We have demonstrably shown that the Ansys simulation tools running on Microsoft Azure's cloud hardware meet the challenges, and we recommend you use them. We encourage you to find out more about the simulation tools we use from Ansys here at Ignite, as well as the hardware we used from Microsoft Azure. You can see more on this project in my talk at the Ansys Level Up Conference on October 25th. Please reach out to us at moshmanresearch.com/contact for more information, questions, or just to connect. Thank you to Microsoft Azure and Ansys for having us at this year's Microsoft Ignite.
One of the key technologies that enabled the mobile revolution to happen is radio frequency integrated circuit, RFIC. Think of them as Wi-Fi. As we demand faster, smaller, and more reliable Wi-Fi devices, we'll be able to do more and more on the go. As a result, there's an increasing demand to accelerate innovations at all levels, from engineering methodology design software to supporting infrastructure to keep up with the pace. To meet this demand, it is now a standard to use simulation software to build virtual prototype before they ever build a physical testbed for testing. Another approach is to shift toward simulating a RFIC as a system on a chip, SoC, instead of each component individually or done via software.
Simulation enabled the Surface team to quickly iterate on industrial design changes to assess performance that otherwise was not possible with prototyping.
This simulation process is critical in designing computers, cell phones, complex radio system, and Ansys has been a leader in this space for the last 50 years.
The accuracy that Ansys and the Surface team achieved was groundbreaking compared to copper cutting style prototyping. The Microsoft Surface antenna and RF team leverage Ansys HFSS as a key technology in designing antennas and simulating radio frequency without costly iterative physical prototyping.
Working together with Ansys, we're able to leverage HFSS to complete an entire RFIC simulation of a 5.5 times 5.5 millimeter at 5 GHz, all under 30 hours. The cloud infrastructure used for this HFSS software run was 704 Intel Xeon cores, working together with no hyperthreading and a total of 2.6 terabytes of RAM. As noted by many, it is easier to gain access to that much Intel-based HPC resources in Azure than on-prem. The VM power the simulation was our XC44, which features a super high-speed InfiniBand interconnect, the same HPC interconnect technology found in today's most powerful supercomputers. Ansys HFSS takes advantage of Intel's AVX512 instruction set that doubles the register size of the CPU to further decrease latency and enhance computational efficiency of the entire simulation. This is a simulation at scale and resolution that was not possible to do just a few years ago. The combination of new meshing technology and HPC advances in both software and hardware made it possible.
Running on Azure has enabled the Surface antenna team to reduce simulation time by up to 40% on the most frequent simulation models.
With this new tool available to RF designers, it will help them to keep pace with the innovation that the market demands. In closing, I would like to use the opportunity to thank Ansys and Intel for their partnership in making this possible today, and we can all benefit from more advanced mobile technologies and products. Thank you.
Today's product design teams need to work more effectively together than ever before. Their engineering tools should inherently support this and work seamlessly with other tools across the enterprise. This is why Ansys Discovery now has collaboration built in and integrated with Microsoft 365. Let's take a look at how this helps Christine develop her new design for a wireless router. Leveraging Ansys Discovery's breakthrough interactivity, ease of use, and speed, she sets up an initial analysis and shares it with Eric to tap into his expertise. Eric is traveling, but reviews the simulation using the Ansys Discovery web application, where he uses built-in commenting to give feedback on the setup in context within the application. All facilitated by the Microsoft Identity Platform, the Microsoft Graph, and Team Sites. Back at the office, Christine uses the rich Discovery application to update her simulation and shares the results with her manager. Tom asks for more design alternatives to better understand the optimal product configuration. Easily setting up parameters for exploration, Christine sends the job off to the cloud. And in mere minutes, she gets thousands of design variations, produces a Word document, and shares it with the team. Getting engineering insights has never been easier, faster, or more collaborative.
Hi everyone, my name is 𝗦𝗲𝗀𝗀𝗀𝗀, Senior Product Manager of Cloud Products at Ansys. Today, I'm excited to introduce everyone to Ansys Access on Microsoft Azure. Ansys Access is an Azure Marketplace offering that enables customers to use their existing Ansys applications along with Azure services purchased directly from Microsoft to deliver cost savings, improve data management, and offer greater compute flexibility. Our goal for Ansys Access on Microsoft Azure is to enhance the development and design processes of our mutual customers through increased productivity, sharper workflows, and greater access to cloud-based CAE tools. Ansys Access will streamline the deployment of end-to-end cloud-based simulation workflows, including both infrastructure such as virtual machines and HPC clusters, and Ansys software. We give customers greater control to store and manage VM configurations, workspaces, and budgets through a single platform. In close partnership with Microsoft, we have developed Ansys Access with benchmarked deployment specifications for quick resource deployments in Microsoft Azure. In addition, customers can leverage any of their existing Ansys licenses and predetermined agreements with Microsoft for utilizing Azure hardware. In summary, we make it fast, we give the customer the control, we make it easy, and cost-effective. Ansys Access on Microsoft Azure will be available for general access in 2024, with private beta preview starting in Q1 2024. Should you be interested in participating in the beta program, please reach out to your Ansys sales rep for more information. For those of you attending in person, please feel free to stop by our kiosk in the industry area to learn more about our latest cloud offering. Thank you for your time and have a great event.